This paper is titled Conditions of Tacit Knowledge Transfer in Architectural Computational Design by the authors Hala, Hossameldin, Ramy, Bakir, and Sherif Elfiki. Our review of the recent research efforts in computational design provided that they are mainly devoted to the development of tangible aspects of the design process, such as technical systems and visual representations. This has allowed for the passage of these explicit knowledge domains from the designer to the computer, neglecting other intangible domains in the design process, such as tacit design knowledge. Despite the few studies that tackle tacit aspects in computational design, research in this area lacks the thorough investigation of the nature and meanings of tacit knowledge and how it can be communicated and represented between design entities in a computational design environment. This research aims to find linkage between computational design and design knowledge through tacit design information. It investigates the conditions and factors needed for tacit knowledge transfer in a trial for expanding the capabilities of computational design tools to incorporate intangible design attributes, particularly tacit design knowledge, and facilitate their flow between different design entities. This paper conducts an analytical literature review that adopts a sequential strategy comprised of three main research goals building conceptually upon each other. The first goal is to identify studies that investigated the definitions and meanings associated with tacit knowledge in different disciplines. The second goal identifies studies that related tacit knowledge to the architectural discipline, especially the ones concerned with computation. Based on the notions of tacit knowledge generated from the first goal, architectural studies that address tacit knowledge in different terminologies were selected. The third goal is to identify literature that addresses human-to-human tacit knowledge transfer. It depends on the outcomes of the two previous goals, in addition to views from other disciplines, which were then compared to the views of disciplines that addressed human-to-computer knowledge transfer. The review of tacit knowledge in different disciplines provided that tacit knowledge is an attribute of humans. It is the quality that is present in every individual's personal contact with the real world, manifested in the skills one acquires, the experience one gains, or one's mere intuition. It further extends to the individual's relationship with others, manifested in his everyday social reflections and interactions with other human beings. The review further provided some individual conditions for tacit knowledge communication addressed by different disciplines, such as practice, individual experience, and expertise, and other social conditions related to personal contact and relationships with other people. Understanding what tacit knowledge means, tacit knowledge in architecture was referred to in different terms, such as design intent, design expertise, and reflection in action. It was noticed that most of the studies that were interested in tacit features within design computation were generally focused on the individual notions of tacit knowledge. Fewer studies, however, were interested in the social notion. This indicated that the computational support of tacit knowledge in design, especially the social aspects of it, needed more investigation in the architecture field. Investigating tacit knowledge transfer between human beings, two sets of conditions were formulated, individual and social. The review emphasized that tacit knowledge transfer entails first and foremost reciprocal interaction in a process of direct exchange of thoughts, ideas, body language, and tacit codes. Furthermore, the presence of a common language, a familiar medium, and the common culture between entities allows for a successful exchange of signs and consequently of tacit meanings. While individual conditions emphasize the personality of the individual managing his own tacit knowledge, having a stance or perspective towards a subject, recalling expertise, practicing skills, and taking decisions. Connecting the previous conditions with the literature addressing human-to-computer interactions, many similarities were found. Regarding the individuality of the computer, authors have emphasized the importance of the computer being adaptable, to be able to construct its own tacit knowledge and build its own repertoire through receiving direct sensory from the real world and overviewing the works of other designers. However, the greater emphasis was on the concept of designer-computer symbiosis and establishing a reciprocal dialogue between the two. Moreover, conditions like establishing a common language and a sign system were addressed in semiotics and HCI, arguing for the possibility of sign interpretation between the human and the computer. The designer then would not have to be a computer specialist or in need of a software engineer to translate his knowledge to the computer. Similarly, this would integrate other entities such as the user to directly express his needs to the machine. Eventually, it becomes a reciprocal interlinking network of tacit information flow between different design entities within a certain context. In conclusion, this research presents a theoretical basis for facilitating tacit knowledge communication between design entities in computational design environments. We argued that the flow of tacit knowledge is reciprocal in nature, just as the study of tacit knowledge should be, where architecture has to be in continuous reciprocal contact with other disciplines to develop more advanced frameworks for tacit knowledge transfer, especially in the computational realm. The research further argued that to study tacit knowledge transfer between the designer and the computer, we have to first take a close look at tacit knowledge flow between human beings and learn from it, which proved to be a successful method concerning the similarities and interlinks found between the human-to-human conditions and the human-to-computer conditions. For future research, we intend to gain a more in-depth understanding of tacit knowledge transfer through theories of phenomenology and distributed cognition. Furthermore, we intend to provide practical evidence for our theoretical framework, investigating the current state of tacit knowledge within computational design practice and the latest AI developments in man-machine design systems. This was Hala Hossameldin presenting the paper titled Conditions of Tacit Knowledge Transfer in Architectural Computational Design, co-authored with Ramy, Bakir, and Sherif.